हेलो, व्हाट्स हैपनिंग? मेरी आवाज साफ आ रही है? आर यू एबल टू हियर मी क्लियरली? यू शुड टू सी मी टू जस्ट राइट अबाउट नाउ. व्हाट्स हैपनिंग? या हे पाई, Rita, how you doing? Yeah, we're going to continue our discussions on electrochemistry. As usual, we'll go into a little bit of detail and we'll first look at the couple of homework questions जो पूछे गए थे. आप में से कुछ लोगों ने इसके जवाब दिए थे. Who gave us answers to these? Hold on, let me just quickly look it up. चलो आप solve करो. If you haven't already solved these homework questions, please करिए. अच्छा, rec. It was rec. I remember now. Rec gave the answer to be 0.772 इस वाले का. Yeah. What do you guys think? Was rec all right? Was he good? Shankar, rec is here. Yeah. Hi Shankar. Hi rec. Hi Pai. The YouTube session link can be seen, huh? It's supposed to be hiding behind me. But anyway, I'm great. Art, how are you doing? We have started the session already. In fact, we are doing homework last session का. तो try करके देखो. जल्दी से try करके देखो and then we'll get started with आज का session right after that. बताइए, what do you think? How do you solve this one? By the way, इसको solve कैसे करेंगे आप? It's quite, like doable in the sense that you have to just make sure that you understand that, look, it is delta G that is extensive and E naught is intensive. मतलब कि आप G naught को आप add subtract कर सकते हो, ठीक है, but not E naught, ठीक है. That is all I'm trying to say here. So what do you think? कैसे किया जाए इसको? Have you tried this? Are you trying it? कैसा चल रहा है? Is it doable? Is it not doable? What do you think? I am just fixing this YouTube link वाली चीज. Yeah, that should be done by now. Hey, I'm good, Art. Shankar, what's up? 0.404 is what Pi is saying. Rec ने कुछ अलग आंसर दिया. How is it 0.404? अच्छा, देखो आपने कुछ पाई, आपने जल्दी में कर दिया. I told you कि इसको कैसे करना है. देखिए, the last reaction that you get is a half reaction, like half cell, right? This is not a full-fledged redox reaction. This is just, what is this? This is just the reduction half. Since इसमें सिर्फ reduction हो रहा है, so you cannot simply add and subtract this. You cannot do that. मैं आपको अभी बोल रहा था कि E naught is intensive. You cannot just add and subtract E naught. The only time you can add and subtract E naught if the number of electrons taking part in the reaction are the same, because it gets cancelled out. यही कहानी थी. शंकर एंड आर्ट. पाई नहीं भाई, आसान नहीं है. आसान तो है, maybe. But why has Rec got the answer of 0.772? Think about it. Rec ने एक आंसर दिया है इस पे. If you see the chat of the last this thing, Rec is saying 0.772. Why did Rec say this then? अभी भी आप लोग वही बोल रहे हो, हाँ? ठीक है, let me go through the details here. इसमें है 3 इलेक्ट्रॉन, इसमें है 2 इलेक्ट्रॉन. डेल्टा G naught वैल्यूज दोनों की मैंने निकाल ली. Now why am I doing all this? Look at this. Delta G naught of this reaction is going to be the first minus the second, which is also going to be NFE. और देखो, इस reaction में N is just 1. You see why you cannot add or subtract those first two things? देखिए, step number 1, check if the final reaction you're getting is a redox reaction or only a half reaction, which is या तो reduction या oxidation. If it is reduction oxidation, तुरंत हो जाइए चौकन्ना. You have to solve it using the idea that Gibbs free energy is extensive, यानी कि आप उसको add और subtract कर सकते हो. Gibbs free energy is NFE minus NFE specifically, or delta G naught is minus NFE naught. That is the idea that I'm using. Okay, that is the idea that I'm using. I've substituted E naught values here. Yeah. हाँ शंकर, we will right now Tuesdays, Thursdays. शंकर अभी तो plan Tuesdays, Thursdays का है. I also take classes on the NEET channel. Yeah, so this is the plan right now. खैर दोस्तों, hey, what's up? NEET aspirant. Yeah. I forgot your first name, यार. NEET, but you told me what your name was. रौनक, रुद्राक्ष. Art, doubt बताइए. देखो यार, so this is how you do this. NFE naught, where N is equal to 1, is going to be equal to this. And you get a very beautiful number, which is 0.772. Yes? Do you understand this, guys? It is not 0.5. It is not 0.4404. शुरू में लगा कि आसान है, but this is not that direct. Shankar, Pi, do you see this? Do you guys see what it was that you guys did? Yeah, last वाला session आपने attend नहीं किया था क्या? In the last session, I explained this in detail, right? The whole way of getting that E naught is additive or if it's not is through G naught. Because बार बार मैं ये बोल रहा हूं, डेल्टा G is extensive, उसको आप add और subtract कर सकते हो. E naught cannot be added or subtracted. कभी कभी आप कर पाते हो add or subtract, that is because number of electrons is the same on reduction and this thing oxidation half reactions. All right, pi शंकर all good. आज डाउट है तो पूछ लो ना यार, मतलब आई हैव अ डाउट बोलने से मैं क्या करूं? ठीक है, कांग्रेट्स, यू हैव अ डाउट, आस्क. नो, if it's related to electro I'll answer, if it's not related to electro ping me on I teach chem, I'll try and help you out on Telegram or Discord. ठीक है, अगला सवाल. When a clean strip of zinc metal is placed in a solution of copper sulfate, a spontaneous reaction occurs. Which of the following observations are made? And Rek gave an answer to this. I'll tell you what Rek said after you guys get it right. Rek got it right, by the way, if you haven't already checked. हाँ नहीं, it's not about I am right. Science is right. I hope you are convinced that this is the right way of doing it. ठीक है, all right, इसको try करो. This is just the basics of this whole concept of अच्छा इस reaction में हो क्या रहा है. Daniel cell में, although Daniel cell आगे है, but ये idea कि zinc और copper sulfate डाल रहे और and a spontaneous reaction occurs, मतलब कि what is happening is zinc is giving you Zn2 plus 2 electron. ये क्या हो गया भाई, Z था, ठीक है, and Cu2 plus is giving you Cu, it's accepting 2 electrons, so it gives you Cu metal. ठीक है, spontaneous reaction मतलब ये दोनों reaction साथ में हो रहे हैं. अब इसको लिख लिया तो बाकी देख लो. Mass of zinc decreases जरूर, क्यों? क्योंकि it's going into solution. Copper metal starts depositing, yes, क्यों? क्योंकि copper solid, right, precipitate etc. Solution remains neutral, हाँ neutral रहेगा. क्यों नहीं रहेगा neutral भाई? न्यूट्रल क्यों नहीं रहेगा? जितने इलेक्ट्रॉन इधर फर्निश हो रहे हैं उतने ही यहाँ पे कंज्यूम हो रहे हैं. न्यूट्रल तो हमेशा रहेगा. टेम्परेचर ऑफ द सॉल्यूशन डिक्रीजेस एज इट इज एन एंडोथर्मिक रिएक्शन. टेम्परेचर ऑफ द सॉल्यूशन, ये वाला थोड़ा अजीब सा है. टेम्परेचर क्यों बदलेगा? सी, फॉर अस एट फॉर ऑल प्रैक्टिकल पर्पसेस, टेम्परेचर, दिस इज अ डिफिकल्ट वन एक्चुअली. टेम्परेचर बढ़ता है कि घटता है इज हार्ड टू नो. इट्स हार्ड टू नो. खैर, फॉर नाउ आई विल मार्क दिस एज अ क्रॉस. And the right answer A, B and C. A, D जो है sounds tricky. I'll get back to you on D. ठीक है, as to how are you going to know? इस वाले के मैं बोल रहा हूँ, ठीक है, सही नहीं है. How will you know some reaction exothermic or endothermic? कैसे मालूम है? We'll think about that. Yes, Art, A is correct, B is also correct, and Pi absolutely right, C also is correct. Rek जी ने यही तीनों जवाब दिए थे by the way. Rek gave A, B and C. चलो, okay, warm up हो गया. Art और Magic, बहुत बढ़िया. A तो सही था, B और C भी था. Art, आप B और C आपको ऐड करना था. साई किरण जी, D is not correct. I know I don't have a very solid explanation for you right now. I'll get back to you on D. ठीक है, क्यों है भाई? टेम्परेचर के बारे में कैसे पता चलेगा? ठीक है, little weird. ठीक है, all right. Let's go ahead and talk about half cell potential. Half cell potential, मैंने आपको बोला था कि there is something called the electromotive force, right? EMF and potential difference. और ये पूरे सेल का होता है, बट सेल का होता है बिकॉज हाफ सेल्स के भी होते हैं हाफ सेल, ये सेल पोटेंशियल्स. डू यू रिमेंबर व्हाट आई एम सेइंग? लास्ट क्लास में आई स्पोक अबाउट द ईएमएफ बीइंग द इलेक्ट्रोमोटिव फोर्स, दैट इज अ टेंडेंसी टू पुश और पुल इलेक्ट्रॉन. अ टेंडेंसी, जैसे उसको पाथ मिलेगा इट स्टार्ट, यू नो, इलेक्ट्रॉन विल स्टार्ट फ्लोइंग. नाउ आई एम सेइंग कि दैट अराइजेस बिकॉज ऑफ दीस रेडॉक्स रिएक्शंस. रेडॉक्स रिएक्शन, रिडक्शन, ऑक्सीडेशन दो हो रहे हैं, तो दोनों जगह इन बोथ प्लेसेस you will have some sort of a potential difference. That is what we're talking about. So potential of single electrode, you can't figure it out. You have to measure it with reference to something else. Okay. The potential difference across two electrodes, yes, इसको आप measure कर सकते हैं. That's what I mean by reference. So potential difference of an electrode is calculated using some sort of a reference. This reference happens to be a standard hydrogen electrode. We will explore this in the third or the fourth session, which will be आज Thursday ना, next Tuesday या फिर Thursday को होगा. We'll explain this in detail. Most likely next Tuesday को होगा third session. उस रेफरेंस का हम लोग बोलते हैं कि उसका पोटेंशियल है जीरो. आर्बिट्रेरी बोलते हैं कि ठीक है, हाइड्रोजन का जो है हम लोग लेते हैं जीरो है. ठीक है, इट्स नॉट आर्बिट्रेरी, या ठीक है. नाउ इफ यू टेक दैट एज जीरो, then with reference to that everything will have a plus or minus something. Okay, so अगर एनोड पे है SHE मतलब होगा ऑक्सीडेशन. If it is at the cathode मतलब होगा रिडक्शन. Yeah, you maybe already know this, so we'll go over this quickly. अगर कुछ ना समझ में आए तो बताना. हाँ रेक, इट्स ओके, मुझे भी डी में डाउट है. मतलब ये क्या टेम्परेचर वाली चीज कहाँ से आ गई है ना? Yeah, but I think you got right. A, B and C I think got me also are right. Yeah. Psi I understand, D was a little random. We'll get back to that one. ठीक है. Electrode potential for क्या कर रहे थे हम लोग? हाँ, hold on. हम लोग कर रहे थे एनोड एंड कैथोड, राइट? सो दिस वन इज एनोड राइट नाउ। एनोड में होता है ऑक्सीडेशन, ऑलवेज रेड कैट एनॉक्स, राइट? एनॉक्स, बुल, एक्स, ऑक्स, व्हाटएवर। सो ऑक्सीडेशन है, यस, इलेक्ट्रॉन्स बीइंग फर्निश्ड। हाँ, इलेक्ट्रॉन्स अगर फॉर्म हो रहे हैं तो ये हो रहा है ऑक्सीडेशन, ओके? सो द ऑक्सीडेशन पोटेंशियल इज गिवन बाय दिस। इज दिस ऑक्सीडेशन? यस, यू आर गोइंग फ्रॉम अ स्टेट ऑफ 0 to +1। redox reactions का बेसिक्स दोस्तों। So under standard state, standard oxidation potential is going to be this value, okay? And for a cathode होता है reduction, quickly going over this, so H plus, वही same H plus that got formed now accepts electrons and forms H2 gas, and here the reduction potential is given by this. Remember, I'm writing it, पहले मैं जो लिख रहा हूँ अब नहीं लिख रहा हूँ, if I'm writing this first, then this is the initial state and this is the final state, ठीक है? How is this reduction? Red cat कैसे? Because again this is 0, this is I'm sorry, this is +1 and this is 0, ठीक है? Delta oxidation number is basically 0 minus 1, which is -1, hence 4i reduction. That's it, as simple as that. Cool. So standard reduction potential is given by this chap over here. So well, they are both going to be 0, ठीक है? Electrode potential of SHE is taken to be 0 at all temperatures, so दोनों 0 है. This will like, यार, what? Why do you even tell me all this? Just you know, making a foundation for everything we're doing. And what we do, as remember, मैंने बोला था कि electrode can be something that takes part in the reaction or it can be just a conductor. So this, in this case, let me just run that quickly. In this case, the platinum electrode is just a conductor, okay? And उसमें जो wire आ रही है, that is where the hydrogen, you know, form होता है, etc. या फिर, you know, gas आती है या फिर 1 molar concentration रखा जाता है. So it is dipped in a 1 molar concentration of an acid and उसमें hydrogen bubbles out, or the other way around, hydrogen जो बन जाता है gas, that can also form more ions, ठीक है? That is what is happening over here at the standard hydrogen electrode. Okay, straightforward stuff. Let's just move on quickly. Okay, so now what is the main point? Now we will try and see कि, okay, say something like zinc, हम उसको couple करते हैं with SHE, standard hydrogen electrode. Once we do that, we will measure it against that, and that is going to give you the potential of that half cell. Half cell मतलब zinc electrode का क्या potential है, that's what we're trying to show. So if we take zinc at the anode, I'll tell you why. Why is this the anode? We will look at the Electrochem series, उसमें हम लोग डिटेल में देखेंगे क्यों ये मैंने क्लियर किया है. But spontaneous reaction will happen if I take zinc at the anode, okay? Remember, this is for a spontaneous reaction. For a spontaneous reaction, I take zinc at the anode, cathode is SHE, and I get E naught cell to be 0.76. Experimental value, ठीक है? What is happening? Cathode में है ये E naught cell is this minus this, so it is cathode minus anode. And what is happening? Both of these are reduction potentials. ठीक है? This was 0, this was this. So from that you get अच्छा, so E naught value is negative 0.76. right? ये क्या हुआ? देखो, E naught cell क्या था? 0.76 volts, right? Now I am telling you that the definition is this. I have told you the definition last time भी बताया था आपको ना कि it is actually, in fact, it is E naught oxidation of anode plus E naught reduction at cathode. Then what I did was, this is the same as minus E naught reduction at anode plus E naught reduction at cathode. This is what we did. Okay? Hence, I have put a negative sign over here, and hence you get this to be the value. Now, using this, the reduction potential is negative 0.76, oxidation potential is positive 0.76. That's it. So, with respect to hydrogen, the gas, zinc has a potential of being oxidized. So, ऐसे ही I cover a lot of things. I take a lot of elements and I say that, okay, let's compare all of them. ठीक है? And we arrange them in this series called an electrochemical series. Before we do this, a quick reminder. ठीक है? EMF is the theoretical idea. Okay? This happens when there is no current flowing. This is the maximum voltage that we can deliver. And this is what we calculate. We calculate this. एक बार आपने cell on कर दी, once you connect all circuits, let electrons flow, potential difference कम होता जाता है until the point you reach equilibrium. At equilibrium, cell dies. Yeah, death of a cell. I'm not being dramatic. That's what it's actually called. That's a scientific term. Here, it's always less than the maximum value of the voltage which the cell can deliver. This basic theory from NCERT, please read up. I'm saying this and this is a positive thing that the JEE main is getting easier and easier, which means you must read NCERT. उसमें theory आपको पढ़नी पड़ेगी. That's a positive thing, but that also means that दोस्तों competition बढ़ रहा है. ठीक है? And I'm saying this because I have gone through all the questions of 2023, 2022, 2021, JEE main के and JEE advanced के. JEE advanced में the only difference is that 2 or 3 concepts are aligned and it's still doable. It is still a little tricky. JEE main, most questions are direct. So please prepare आराम से NCERT को पढ़िए. मैं बार-बार यही बोल रहा हूँ आप लोगों को. Oh, as always, please solve the back of the book questions as well. Okay, let's get back to electrochemical series. Electrode should be exhausted for cell to die? No, Sai. No, that's the beautiful thing. It does not have to be exhausted. It just has to reach equilibrium. Equilibrium means delta G equal to 0. Delta G equal to 0. E equal to 0. As simple as that. है ना? है ना? Resistance EMF is more than potential difference. Yeah, this is very interesting. Sai Kiran is saying interesting stuff. Electrode should be exhausted का मतलब मैं भी समझा नहीं. Exhausted मैं समझ रहा कि भाई पूरा electrode खत्म हो गया. Like went vanished in thin air. If you mean exhausted, if you mean this, then yes. Okay, let's get back to this. We'll talk about what Sai is saying in the next session. Our next equation, we'll talk about all of this in detail. So anyway, electrochemical series. Electrochemical series ka, the way it is reported is that you take the reduction potentials, okay? The reduction potential, this is important, okay? Whatever सवाल में जो भी दिया हो, electrochemical series is going to be reduction potentials, okay? What that means is I will arrange them in what order? Let's start with the most negative, okay? And then we go to 0 and then go to the most positive, which means they are arranged in a sort of a order, right? Now, what does it look like? Here is an example. So you start with, I'm sorry, not most negative, most positive. Ulta मैंने लिख दिया, right? Let me correct that. Standard reduction potentials for various half cells are measured at blah, blah, blah. Most positive to most negative through 0. Decreasing order. मतलब कि most likely to get reduced. To get reduced. And this is least likely to get reduced. Okay. मैं बार-बार इसको लिख रहा हूं because this theory is what is tested in JEE main. I'm not even kidding. I'll tell you the kind of questions that come in JEE main very quickly. So here are the values. मतलब this guy here, this really likes being reduced. If it really likes being reduced, it is a good oxidizing agent. Almost entirely, मैं बोला था, मैं थोड़ा देखा था 2023 से 2021 के पेपर्स में. This concept of what is oxidizing agent, what is reducing agent, यही बार-बार पूछा जाता है इस सेक्शन के of electrochemistry. So this is a very good oxidizing agent because it is getting reduced. खुद हो रहा है reduce, मतलब good oxidizing agent. It's causing something else to get oxidized. What is there something else? Whatever it may be, it doesn't matter. ठीक है? Value gets reduced, कम होता जाता है, number कम होता जाता है. बहुत यहाँ पे दिया हुआ है. It's okay. You look at this later on. ठीक है? बाद में देख लेना. खैर, and it goes all the way. जीरो कहाँ है भाई? बहुत ढेर सारे. कॉपर भी यहाँ पे आ गया. कॉपर भी हो जाता है reduce. हाँ, आ गया जीरो. तो जीरो के बाद जो भी नेगेटिव है ना, all of these नेगेटिव मतलब नॉन स्पॉन्टेनियस. मतलब कि अगर मैं इसको बाय इटसेल्फ देखूं, देन लुक्स लाइक दीज आर रिड्यूसिंग एजेंट. एंड देखिए, द कॉन्सेप्ट ऑफ अ रिड्यूसिंग और ऑक्सीडाइजिंग एजेंट इज अ रिलेटिव टर्म. ये एब्सोल्यूट टर्म तरह से कोई नहीं बोल सकता कि रिड्यूसिंग है या ऑक्सीडाइजिंग है. यू हैव टू कंपेयर इन नॉट वैल्यूज क्वांटिटेटिवली एंड देन यू कैन टेल दैट इज व्हाट इज बीइंग टेस्टेड इन इलेक्ट्रोकेमिस्ट्री. बट अगर नेगेटिव वैल्यू है, you can maybe for one set a very negative. Look at this lithium, ये सबसे ज्यादा नेगेटिव है, तो ये तो डेफिनेटली होगा भाई रिड्यूसिंग एजेंट बिकॉज इट लाइक्स बीइंग ऑक्सीडाइज्ड. ओके, मतलब ये रिएक्शन होगा उल्टा. ओके, ऑपोजिट डायरेक्शन. इफ द रिएक्शन गोज इन द ऑपोजिट डायरेक्शन, दैट मींस देन दिस लाइक्स बीइंग ऑक्सीडाइज्ड. इफ इट लाइक्स बीइंग ऑक्सीडाइज्ड, इट इज अ वेरी गुड रिड्यूसिंग एजेंट. मैं बस ये बोलना चाह रहा हूं, ये है क्वालिटेटिव आइडिया. ओके, क्वालिटेटिव आइडिया. क्वांटिटेटिव के लिए quantitative compare E naught values. What do I mean? एक सवाल करते हैं फिर तुरंत समझ में आ जाएगा. Okay? Yes, good oxidizing agent to bad oxidizing. Yes, REC. I like that. जो REC ने बोला हम लोग वही अभी देखेंगे. Highest reduction potential to lowest reduction potential. Okay, that's how we are arranging these. और कुछ आ रहा है यहाँ पे? Yes, electrochemical series, that's what it's called. And I think there's something more or nothing else. That's it. Also activity series, what you have learned in 8th, 9th, 10th. Is that it? Oh, that's the next one. I think I have another one for you. Here it is, the actual numbers, right? Very positive, goes down, etc., etc. It's okay. This is fine. Let's move on. Okay, what's the application? We'll figure out what is a good reducing agent, what's a good oxidizing agent. So good reducing agent are all of these metals because they like being oxidized. So they are good reducing agents. Okay. And if they have a highly positive standard reduction potential, then they're going to be good oxidizing agents. Like all of these, they like being reduced. By like, I mean thermodynamically. You will learn this, or maybe you already know this, that there are two aspects to any reaction. One is thermodynamics and the second is kinetics. मतलब thermodynamics says कि energetically favorable है कि नहीं, but kinetics decide कि actually हो रहा है कि नहीं हो रहा है. Yeah, KSP and all of that, a lot of things. खैर anyway, won't bore you with that. Anyway, फिर से ये आ गया हमारा दोस्त. Let's move on. कितने चैप्टर्स कंप्लीटेड हो गए शंकर, हमको क्या मालूम, आप बताइए. आप चैप्टर्स हमको आपको कंप्लीट करने हैं. आई एम हियर टू हेल्प यू कंप्लीट योर चैप्टर्स. यू टेल मी, आई विल हेल्प यू कंप्लीट व्हाटएवर चैप्टर. The reason I picked up electrochemistry is because it uses ideas from thermo, gas state, equilibrium, सबसे, right? तो मुझे लगा इसको पहले कर देते हैं. लेट्स डू दिस बिकॉज कुछ स्टूडेंट्स को ये मुश्किल लगता है. बाकी तो मैं आपको वीकेंड्स में आई एम मीटिंग ऑलरेडी. वीकेंड्स में आई एम डूइंग क्वेश्चन सॉल्विंग सेशन ना, वो तो आप आते आ जाओ. दैट्स गोइंग टू हैपन एनीवे. उसके साथ आई एम डूइंग इलेक्ट्रोकेमिस्ट्री इनसाइड आउट. ठीक है, दैट्स द प्लान. ए neat guy, that's awesome. Sorry, आपका नाम मैं भूल गया. Rudraksh, yes, thanks. Okay, what's the application of electrochemical series? Right, more active metals can displace less active. Now this is the main, what do you call it, makhan jo hai, what you're talking about. That's important. I'm hungry now. So copper sulfate plus zinc, this reaction happens, this reaction does not happen. Why? Because the conjunction, because bhai, this is negative 0.76, this is plus 0.34. What is this? This is reduction potential. So, if you try and make a E naught cell, if you make a E cell and it turns out to be positive, then yes. If it turns out to be negative, then not. Quickly देख ले positive है कि negative है. देखो, ये है cathode. If I put this at the cathode, I put this at the anode, then everyone is happy, right? This at cathode, this at anode will give me a potential of 1.1 volts. This is summary ना, मतलब यही तो करोगे अभी. Daniel said we'll do that only. ठीक है. इसमें क्या हो रहा है देखो, negative 0.76 which is cathode, right, and anode is going to be negative 0.34, right, that's giving me negative 1.1. तो ये reaction नहीं होगा, but I can make that reaction happen. How? Pass electricity greater than 1.1 volt और ये reaction भी हो सकता है. That is the most beautiful thing about electrochemistry. Even a non-spontaneous reaction, if you find out the value, this negative value, if you supply E naught greater than that, the reaction हो जाएगा. That's the point. खैर, एक क्विक छोटा सा आसान सा सवाल. How many of the following metals release hydrogen gas when reacted with water or steam? This you have been studying since 9th standard. ठीक है. So please tell me the answer to this. बताइए इसका आंसर क्या है? Sir, this zinc displaces copper sulfate during electrolysis or even upon mixture. देखो, zinc will displace copper sulfate as it is. Electrolysis मतलब you're passing electricity to make a reaction happen. That's not needed here. You're not to pass electricity. Here a chemical reaction will happen and you could generate electricity from it if you separated them. We'll look at that. Abhi Daniel cell karenge, we'll look at that. Okay. Yes, PEC Chandigarh is a beautiful college. I have friends who have studied there. Rudraksh, हम तो मिलते हैं, daily मिलते हैं. Almost, 3-4 days a week we meet. Pranav, yeah, it's a great college. Absolutely. Okay, इसका आंसर बताइए. How many of these metals release hydrogen gas when react with water or steam? Sai is saying 1, 2, and 3. Okay. What about the rest? Water or steam? Water or steam. मतलब कि hot water. Only the first 3. What about the rest? देखो, I'll give you a hint. If it is above H, it will work out. Which means all of these, all 9 of these, 1, 2, 3, 4, 5, 6, 7, 8, 9. All of them will release H2. I'm just going to quickly check that for you on the internet because you guys, a lot of you are saying 3. मतलब aluminum नहीं करता क्या? Does aluminium react with hot water or steam? पूछ लेते हैं इंटरनेट बाबा से. Metals like iron, aluminium, zinc do not react with cold as well as hot water. Metals like Fe, aluminium and zinc react with steam to form metal oxides and hydrogen. They react with steam, दोस्तों. I'm reading this off the Baidu's website and also a lot of websites. ठीक है? Cool? Okay? You're okay? ऐसे सवाल आ सकते हैं, जेईई मेन में आ सकते हैं, एंड दिस स्टफ यू नो फ्रॉम 9th ग्रेड. हॉट वाटर के साथ नहीं करता, बट स्टीम के साथ रिएक्ट करते हैं. व्हाट्स द मेन आइडिया? शंकर, राइट अबाउट व्हाट? Sorry, I didn't know. 682. अच्छा. All 9 of them, guys. That's the rust takes a lot of time. Let it take time. क्या फर्क पड़ता है? Steam के साथ it will release H2. It will release H2. Sai, Shankar, you are right partially. Okay. All of them. These. So 9 is the answer. ठीक है? Think of this like a numerical entry question. The answer will be 9. Okay? Don't worry about it. Right, wrong, कोई फर्क नहीं पड़ता है. Activity series. Exactly, pi. That's why I said 9th standard में पढ़ा है इसको. 9th या शायद 10th में. 9th में ICSE में, 10th में CBSE में. Right. खैर, anyway. I have taught यार, मैं क्या करूँ? I have taught ICSE state boards. I get confused sometimes कि what is where. But कहीं ना कहीं 6 to 10 में पढ़ा गया है. Yeah. Made a lot of videos. खैर, application क्या है इसका? Okay. Oxides of active metals are thermally stable. आई, ये क्या नई चीज आ गई? Thermally stable. अच्छा. So if it's an active metal, is going to form a thermally stable. Garam karo. This, in fact, you know, is like over 1000 degrees Celsius, right? 1 2 something Kelvin, 1280 Kelvin or something like that. पे ये CaO dissociate होता है to give you calcium and all that. No, not CaO तो नहीं भी होता है. That is CaCO3 होता है. CaCO3 होता है. CO तो not नहीं होता. Less active metals come thermally stable. A little bit of inorganic chemistry. ठीक है? Cool. Okay. Here is the question. चलो. Everything except gold, silver, copper. Absolutely right, Sai. Here's the question. See, this is asked in JEE 2019. And इससे आजकल के सवाल are easier than this. I am not saying this just to boost your confidence. आप अगर चाहो तो कुछ भी देख लो, खुद भी देख लो. The questions that come today are easier than these questions. But you try this one out. ये भी direct ही है. Consider the following reduction processes. You've got this, you got this, you got this, you got this. And you've got a bunch of E0 values. The reducing power is what you have to figure out of the metals increases in what order. Try karo. Yeah, try karo please. While I fix the alignment. Yeah, man, my life and PPTs is just, this happened in the NEET session as well. मैंने जो सब चीजें सुबह अलाइन की थी, वो सब भाई साहब बोल रहे कि nah, I'm not going to be aligned. So yeah, we do a bit of fixing on the fly. Yeah. Khair, what do you guys think the answer to this one is going to be? A. Okay. Are you sure it's A? A. Bro. Reducing power. A. I'm not saying the answer is A. I'm like, bhai, aap log A kyun bol rahe ho? Okay, let me go back one step. There's a song by Def Leppard called Two Steps Behind. It's a very nice song that comes to my mind right now. I'm not going to sing it. You should check it out. Two Steps Behind, Def Leppard. DEF, not DEF. Not Behra, but DEF. Yeah, two steps behind. Anyway, so, this is the most negative. So, this is the strongest reducing agent. मैं बहुत धीरे धीरे लिख रहा हूं ताकि ये बात दिमाग में बैठ जाए. Why is the strongest reducing agent? Because the reverse of that reaction has a positive EMF. Okay, let's say positive E0 value. Okay, reverse of that. What does that mean? It likes being oxidized. If it likes being oxidized, it reduces everything else. Okay, so the most reactive it's going to be either this or this, not this, not this. ये बात सही है. अगर ये हो गया, then look at the one that is the smallest, zinc. तो zinc should be, नहीं zinc नहीं, zinc से भी छोटा है, nickel. तो निकल होगा सबसे पहले. तो हो गया ये आंसर बी. ठीक है. Slow and steady wins the race, guys. Be the tortoise. Turtle, जो भी बोलना चाहो. Yes. DACB. DACB. शंकर जी उसका उल्टा हो गया. साई किरण, yes. A lot of your retracting messages, it's okay. It's all right. ध्यान से करो दोस्तों. Right? The reason I'm taking things slow, a lot of you say, यार, you want to solve questions. आप लोग सब बहुत जल्दी में हो. It's time to slow things down. JEE is not an exam जहां पे आपके पास हैं बहुत ढेर सारे सवाल. You have 25 questions and 1 hour. है ना? तो आराम से करो. 4 मिनट पर क्वेश्चन. किस टेस्ट में मिलता है इतना टाइम? एडवांस में तो और भी टाइम मिलता है. This is not a race against time. Okay? What you know, you mark. If you score 50 to 60% of the marks correctly, no negative marking, यू आर गेटिंग एन अंडर 5K रैंक यार, और क्या चाहिए लाइफ में, है ना? प्लीज, स्लो एंड स्टेडी विंस दिस रेस। ओके, ये समझ में आया? शैल वी मूव ऑन? We are at a very good pace in terms of the time of the class. Yeah, we are doing good, don't worry. जो मैंने प्लान किया will get done. Is this okay? How it's be? I gave you a detailed explanation over here on this slide. Yeah, is it okay? Shall we move on? Guys, बता दो. Yeah, I believe in quality over quantity. So I will do some questions, but we'll do it inside out ताकि you'll never forget. नहीं शंकर, सॉरी की बात है ही नहीं. I want you to take away something positive once this session is done. During the session, जितना आपको करना है आप लोग टाइम पास कर लो. By time pass, I mean you please respond. Give me what your opinion is. Then I'll understand what I need to teach you to make sure you understand correctly. ठीक है? All right, let's move ahead. No sorry, no thank you, not. We are doing this. What will occur if a block of copper metal is dropped into a beaker containing a solution of 1 molar ZnSO4? What will happen? What will happen? Suspense. क्या होगा? अमिताभ जी की आवाज में. नहीं, let's not defame अमिताभ जी. What's going to happen here? 4 ऑप्शन है, पढ़ लो भाई, पढ़ के बताओ क्या. The copper metal will dissolve, zinc metal will be deposited. The copper metal will dissolve and oxygen gas निकलेगी. वाह बेटा वाह. The copper metal will dissolve and hydrogen gas निकलेगी. सही है. No reaction. Look at the fourth one. Huh? Is that a distractor option or is that the correct option? क्या हो सकता है बताओ? Sai is very confident about D. हाँ, 25 in chemistry, 720 नीट. अरे 720 क्वेश्चन थोड़ी ना होते यार नीट. रुद्राक्ष, हाँ, स्पिनिंग टेल्स. रुद्राक्ष, कम ऑन यार, नाइस स्टैट्स. 720/4 मतलब कितने होते हैं सवाल? 240 क्या? नहीं, गलत मैथ्स किया मैंने. 16 150 व्हाट, 50 50 100 200 क्वेश्चन होते हैं ना नीट में, इज व्हाट आई थॉट. नो, होल्ड ऑन, आई एम ऑफ हियर. खैर, साई सही बोल रहे थे यार. साई यू आर राइट. नो रिएक्शन लकर ब्रो, यू आर एब्सोल्युटली राइट. डोंट चेंज योर आंसर. पाई इज सेइंग ए, ठीक है, एंड Rek is saying D. Okay, Sai said D and then change their answer. IAS शंकर, वाह. IAS के लिए आपको IAS, yeah, that's a long game, huh? We'll talk about IAS another time. Maybe ping me on I Teach Chem. I have some friends who have taken that journey. So yeah, ping me. I guess we'll talk about IAS. 180, 180, 360. Yeah, you're right. So how much is that? 45 questions each. Yeah, 45, 45, 90, right? And कुछ optional भी होते हैं, ऐसा कुछ होता है, or 50 or do some 45 or something like that. खैर, so 45 questions there in 1 hour. Here 25 questions an hour, right? तो आपको जल्दी नहीं करना है. In NEET जल्दी करना है. In NEET you have to be quick, which means you have to read question very quickly. You have to identify क्या essential assertion जो भी करना है तुरंत करना है. But in JEE you have time in life. I'm not saying one is better than the other. I'm saying they're two different exams, so treat them differently. It's all right if you're giving both. ठीक है, दे दीजिए. But you got to prepare for them अलग अलग से. खैर, let's move on to what is a galvanic cell. Are you okay? How उसमें D क्यों था? मैंने explain नहीं किया ना. Sorry, my bad. In all the drama, I forgot this. देखो यार, copper plus ZnSO4 is not going to happen. No, negative 0.34. Sorry, positive 0.34, negative 0.76. These are what? Reduction potentials. Okay, ये हम चाह रहे हैं. We are trying to oxidize this. क्यों होगा ये ऑक्सीडाइज? ये ऑक्सीडाइज तब होगा if you had something lower than copper in the series. कॉपर के और भी नीचे, like I don't know, something else like tin or whatever else that is even more positive, not tin, say gold or something और भी है, तब हो जाता कॉपर ऑक्सीडाइज. बट विद जिंक नहीं होना है, नहीं होना है. ओके, इट्स ओके पाई, इट्स ओके. Slow things down, you will get this. Galvanic cell. क्या होता है galvanic cell? Spontaneous redox reaction used to produce electricity. That was the first part of this session. Electrochemical series हो गया खत्म आधा घंटे मार्क पे. Now we are going into Daniell cell, which is a type of galvanic cell, right? Galvanic cell मतलब कि reactions leading to, well, producing electricity. अभी तक we've been talking about some redox reactions, कुछ electrons. Now what we are going to do is we are going to manipulate that. We are going to make sure that those electrons flow in some sort of an external circuit, जिसकी वजह से आप उससे इलेक्ट्रिसिटी यानी कि ऊर्जा निकाल सके. Yes, रुद्राक्ष, absolutely. दोनों चीजें, नीट में बहुत कॉन्सेप्ट चाहिए होते हैं, एनसीईआरटी में बहुत ब्यूटीफुल बुक, इट वर्क्स फॉर बोथ जेईई एंड नीट. खैर, it's built by two electrodes. Say example, in this case, Daniel cell is zinc rod dipped in ZnSO4 solution, copper rod dipped in COS4 solution. Everything you've learned so far just culminates into this idea. ये electrode में क्या होगा? Tendency होगी to form this. Okay? And इस electrode में क्या होगा? Tendency होगी for this. What does this mean? This means that from solution to electrode पूरा लिख देता हूं. What solution? Electrolytic solution, right? Copper sulfate. And इसका क्या टेंडेंसी है? From electrode to what? To solution. मतलब Zn2 plus being formed. And बार बार बोल रहा हूं, electrons furnished मतलब कि ऑक्सीडेशन. ओके, और कहां लिखे? मेरे सर के ऊपर लिख देते हैं. ओके, इलेक्ट्रॉन्स कंज्यूम्ड यानी कि रिडक्शन. ठीक है, हैंडराइटिंग थोड़ी अजीब है, टॉलरेट कर लो. बड़ा बड़ा इसलिए लिख रहा हूं ताकि यू गाइस नेवर फॉरगेट इट. यू विल गेट दिस पीडीएफ, मिल जाएगा यार टेलीग्राम में. ज्वाइन द टेलीग्राम, डिस्क्रिप्शन में होगा. इफ यू आर नॉट वाचिंग लाइव, डिस्क्रिप्शन होगा. लाइव देख लो तो इट्स ओके, अभी भी डिस्क्रिप्शन में है, देख लेना. नोट्स डाल दूंगा मैं बाद में, कुछ लिखने की जरूरत नहीं, सुनो बस. टू इलेक्ट्रोड्स, जिंक इन ZnS4, मैंने बता ही दिया यार. देखो ये फैंसी सा डायग्राम है, वही दिखा रहा है. ठीक है, दिस इज जिंक, ये जो कलर है इसका, दीज आर ऑल जिंक एटम्स, एंड थोड़े से यहाँ पे आयॉन्स है. ठीक है, एंड टेंडेंसी क्या है कि जिंक विल ट्राई एंड गेट इनटू सॉल्यूशन लाइक दिस. दिस इज ऑक्सीडेशन. ठीक है, एंड देयर इज अ डबल लेयर दैट इज फॉर्म्ड. ओके, एंड हेंस देयर इज अ पोटेंशियल डिफरेंस बिटवीन द रॉड एंड द सॉल्यूशन. मतलब कि क्या, इधर देखो, हियर देयर इज अ लेयर called a double layer. We'll talk about that maybe in a later session. If you guys want, we can talk about it. It's called Helmholtz double layer. पढ़ लेना उसके बारे में. Because of which there is an electrode potential that is there. Remember that the EMF exists when there is no current that flows. As soon as you try and draw current out of it, it keeps falling until the reaction goes to equilibrium. Copper sulfate क्या हो रहा है? Same thing. Yeah, this is copper colored. I put it in COSO4 solution. ये blue इसलिए क्योंकि ये copper sulfate है. ठीक है, ZnSO4 कौन से कलर का था? I don't think I had any color. Did I have any color? Nah, it's colorless. All right, sweet. क्या बताएं आपको? हाँ? Oh, okay. Shankar is what? I don't understand, dude. Shankar, I don't follow what you're saying. समझ नहीं पाया. सही है. What's your real name, Rekha? Okay, cool. Let's focus. थोड़ा सुन लो यार, थोड़ा सुन लो. We'll have questions coming up. Okay, कहानी बता रहा हूं ताकि आप लोग सवाल सॉल्व कर पाओ. From this electrochemical series, the E naught of this, when I write it like this, these are both reduction potential. ध्यान से देखो, पहले लिख रहा हूं मैं ion and then reduced species. मैं reduced species इसलिए बोल रहा हूं क्योंकि कभी कभी you can have metal or you could also have another ion. It's possible. Okay, when we look at say MnO4 minus to Mn2 plus, that's two ions. I will talk about this later. ठीक है, अगले सेशन में बात करेंगे इसकी. खैर, anode is going to be zinc half cell, cathode is going to be copper half cell. How? Because of this. Yeah, because of this. This is negative 0.76, this is 0.34. So only if I make this the anode will this have a E naught that is positive. Only then. ठीक है? Yes, we will teach, absolutely. पढ़ाएंगे, क्यों नहीं पढ़ाएंगे, रुद्राक्ष जी. Oxidation anode, it has a negative polarity because it is furnishing electrons. अगर वो दे रहा है इलेक्ट्रॉन कहां से आते हैं? बैटरी के नेगेटिव टर्मिनल से. तो आपने बैटरी तो बनाई. दिस इज अ बैटरी और अ सेल. बैटरी इज 2-3 cells together. Daniel cell, negative electrode is what? Anode. How do I know this? इसको मग नहीं करना है, उसको आप रिडॉक्स से समझोगे. अगर वो फर्निश कर रहा है एक्स इलेक्ट्रॉन्स तो वो होगा एनोड. वी लुक एट व्हाट हैपेंस इन इलेक्ट्रोलिसिस लेटर. ठीक है, अभी के लिए ठीक है, अभी के लिए ठीक है. या द इलेक्ट्रोड पोटेंशियल इसका उल्टा, दिस इज ऑक्सीडेशन पोटेंशियल दैट इज रिटन टू बी दिस वे. अगेन फर्स्ट द 0 एंड देन 2 प्लस. तो दिस इज ऑक्सीडेशन पोटेंशियल. ध्यान से देख लेना ये सब चीजें. ठीक है, रिडक्शन पोटेंशियल is given by Cu2 plus by Cu. Positive polarity, why? Because यहां पे हो रहे हैं consume electrons. If something is pulling electrons, it must be positive. Think of a battery, right? बैटरी में क्या होता है, बैटरी या सेल में क्या होता है, रेगुलर AA, AAA बैटरी, you got a positive terminal, negative terminal. Electrons flow from negative to positive. Current flows opposite direction. All this you know from physics. वही चीज बता रहा हूँ, वही चीज बता रहा हूँ. यहाँ पे copper 2+ is accepting electrons. मतलब it's pulling electrons. So it must be the positive terminal. Okay? Okay? Reduction हो रहा है and it is positive. ठीक है? Sweet. Yeah. But why does the polarity change? Rudraksh. क्यों? Why does the polarity change is what I'm asking. Right? You got to figure that out. ये लोग वही एक्सप्लेन करने की कोशिश कर रहे हैं. On joining the metal strips through a wire, इसमें assume को resistance नहीं है, current flow करेगा as long as there is a potential difference between the metal and the liquid phase. मतलब वो जो बाउंड्री है, जब तक पोटेंशियल डिफरेंस रहेगा तब तक होता जाएगा रिएक्शन फ्लो. बट ये जो रिएक्शन है, इट्स नॉट सस्टेनेबल. क्यों? क्योंकि अक्यूमुलेट हो जाते हैं चार्जेस. देखो, अगर मैं इलेक्ट्रॉन्स ले रहा हूं और जहां पे आयॉन्स आ रहे हैं, so there is an imbalance being created. What kind of imbalance? In the solution, there is a dearth of Zn2 plus and extra Cu2 plus. Dearth मतलब कम हो गया. Okay, that's what I mean by dearth. That's what the word dearth means. Okay, this is in the anode half cell. This is in the cathode. So there are extra. There's a charge build up. Okay, that's not good. That's not good. Sure, electrons बाहर जा रहे हैं, बाहर circuit से जा रहे हैं, but inside this there's a problem. Okay, so there's an equilibrium established, and that is called the death of the cell, and that's not good. That's not good. Okay, extra positive charge in the solution will not allow zinc ions to move in the solution, and will be saturated with too many zinc ions. हमने उल्टा बोला क्या? रुको, dearth of Zn2 plus बोला, उल्टा लिख दिया, exactly उल्टा लिख दिया. Brilliant, brilliant. Extra Zn2 plus on anode. और यहां पे हो गए एक्स्ट्रा नहीं, यहां पे हो रहे कम हो गए कॉपर 2 प्लस, राइट, बिकॉज द रिएक्शन इज CO2 प्लस प्लस 2 इलेक्ट्रॉन्स गिविंग Cu. हाँ, इट्स ओके, किसको याद रहता है, वील फिगर इट आउट. नो, वी नो फॉर श्योर कैथोड में हो रहा है रिडक्शन, तो वील राइट इट. उसमें क्या है, एनोड में हो रहा है ऑक्सीडेशन. एक्स्ट्रा क्यों? बिकॉज यू गेट Zn प्लस गिव्स यू दिस. ठीक है, कूल. ओके, जीटा पोटेंशियल अलग बला है. जीटा पोटेंशियल हैज टू डू विद कोलॉइड्स. Oh, the double layer. You're talking about the Helmholtz double layer. Yes, that's zeta potential. Here it's called the liquid junction potential. Yeah, you're right. Thanks for correcting me, Rudraksh. Zeta potential has to do with the Helmholtz double layer, which is in colloids, not over here. छोड़ो इसको. Let's focus on what's over here. Death लिख दिया, which looks scary. Yeah. So you got extra Zn2 plus ions, and that's not good, right? At all times, two reactions are happening simultaneously. What two reactions? This and this. Zn2 plus coming out and zinc metal being formed. Okay, दोनों चीजें हो रही हैं. That's why there's a double-headed arrow over here. This double-headed arrow signifies equilibrium, which is this. Let's remove the word death. It looks scary, right? Let's remove that. Anyway, at the cathode, same cheese. There's going to be an equilibrium, and here in this case, Cu2 plus हो जाएंगे कम. Okay, there will be accumulation of a charge over here. Will not allow more copper to get deposited. Why is there accumulation of charge? Because ये जो electrons हैं, they'll keep going out. तो यहाँ पे आके भाई साहब ये बैठ जाएंगे, बोले कि भाई, give me some place. I have no place. Again, there are two processes happening in parallel. What are the two processes? You guys already know this, but I'm just putting this out here. यहाँ पे Cu2 plus being formed, and यहाँ पे है copper, यहाँ पे जो बैठ जाते हैं भाई साहब. ठीक है? Okay. Yeah, that just became the highlighter by mistake. So how do I get sustainable current from this? We'll answer that. पहले एक सवाल देखते हैं. वाह वाह वाह. Look at this amazing. Oof. इस सवाल को ट्राई करो आप लोग while I fix the alignment. Wow, अभी भी नहीं फिक्स हुआ. और छोटा कर देते हैं. Have you seen that ad? Like कि एक बेलांग छोटी कर दो. There was that what do you call it? शायद किसी चॉकलेट का एड था. एनीवे, अभी पढ़ पा रहे हो ना? दिस फाइन. सो यू गॉट स्टैंडर्ड इलेक्ट्रोड पोटेंशियल डेटा. क्वेश्चन ये है कि आइडेंटिफाई द ओनली इनकरेक्ट स्टेटमेंट रिगार्डिंग द क्वांटिटेटिव एस्टिमेशन ऑफ FeNO3 होल ट्वाइस. आई FeNO3 होल ट्वाइस. अच्छा, क्वांटिटेटिव एस्टिमेशन. क्वांटिटेटिव कैसे करोगे? रेडॉक्स रिएक्शन से. दिस you will hold out something called a redox titration. It is as simple as it sounds. In एक बीकर में आप लोगे कुछ और ऊपर से आप ड्रिप करोगे कुछ, you will use something as an indicator. That's it. You will know the known quantity of this thing, you will know the molarity of something. एक चीज की मोलैरिटी नहीं मालूम होगी, उसकी मोलैरिटी निकाल के you will get अच्छा इतने इक्विवेलेंट्स रिएक्ट हुए तो इसमें होंगे इतना इतना परसेंटेज प्योरिटी ऑफ दिस. ये सब you have solved in redox. Solve नहीं किया तो ठीक है, we'll solve. Don't worry. But this is not a big deal. What is a big deal is this. You've got to figure out कि अच्छा इनमें से incorrect कौन सा है. So how will you figure out something is correct or incorrect? Check if E naught is positive and also check अगर एक के बजाय दो रिएक्शन हो रहे कहीं पे. Sometimes you want just one reaction to happen, but अगर उससे ज्यादा रिएक्शन हो रहे हैं, that's not good. These are two things to check for. Yeah? Shall we try this out? या फिर ये ज्यादा भारी हो गया? Do you want me to help you solve this? I can do that if you want. I can explain this one for you. See, what is happening here is in the first reaction, it says कि 1.51 volts है. इसका 1.38, इसका 0.77, इसका 1.4. So for me to estimate aqueous FeNO3 whole twice, I will want to go from Fe2 plus to Fe3 plus. So if I go in that direction, I have to reverse this reaction. So if I reverse this reaction, इसका हो जाता है negative 0.77 volts. So along with this, if I take any of these guys, will the reaction happen? It looks like सबके साथ होगा, because if I subtract 0.77 from all these reactions will happen. So then I should be able to सब होंगे सही नहीं, but इसमें एक ही incorrect होना चाहिए. Identify incorrect. So I think मेरे हिसाब से ये तो यूज ही कर सकते हैं. Cr2O7 in aqueous HCl, मतलब दिस इज सेइंग कि एसिडिक मीडियम में Cr2O7 यूज करो, माइनस 0.77. थोड़ा क्लीनली लिख देते हैं यहाँ पे, ठीक है. रिवर्स ऑफ दिस रिएक्शन. सो दिस एंड दिस इज एसिडिक मीडियम, दिस इज HCl, सेम एज दिस गाय हियर, नॉट HCl ओवर हियर, ठीक है. इसमें है HCl. ओके, वी यूज दिस. MnO4 कैन बी यूज्ड इन aqueous H2SO4. यस, ये तो स्टैंडर्ड चीज है. Cr2O7 कैन बी aqueous, ये भी ठीक है. तो सवाल आता है सिर्फ पॉइंट ए पे. क्वेश्चन ए इज व्हाट यू गॉट टू आइडेंटिफाई. हाय भवेश, हाउ यू डूइंग? हाउ यू डूइंग भवेश? आर यू फ्रॉम रेडिट? सो are you okay with B, C and D guys? H2SO4 and MnO4 minus, that's a standard thing that you know from DNF block. Same with Cr2O7 with H2SO4 is standard. But HCl में क्या प्रॉब्लम हो सकती है? HCl में प्रॉब्लम ये हो सकती है कि MnO4 minus is a very very strong oxidizing agent. जगह है थोड़ी लिखने के लिए, जगह तो बना लेंगे. Strong oxidizing agent, यानी कि MnO4 minus ऑक्सीडाइज कर देता है इसको. MnO4 minus will oxidize Cl minus. So it cannot be used. It cannot be used in aqueous HCl. This H plus needs to be H2SO4. Okay, that is a small deal, and technically I think this question belongs in DNF block than in electrochemistry, but मैंने यहाँ पे डाल दिया because I guess I'm a little sadistic, right? But it's okay. ठीक है. Bhavesh, okay, school wise, okay. Bhavesh, ping me on iTeachChem so that we can chat, I guess, on Telegram or on Discord. Yeah, let's focus on this electrochem class right now. Do you guys follow this now? Shankar, Rek, everybody else? Can I show E naught values? है तो मेरे सर के ऊपर लिखी है. Show मतलब 1.51 minus 0.77, 1.38 minus 0.77, 1.4 minus 0.77. So theoretically, all of them can oxidize this. But the problem is this, right? I need to have H plus. Only acidic medium में ये दोनों होते हैं. But that acidic medium is created by H2SO4 and not HCl in the first reaction. क्योंकि MnO4 minus is a strong oxidizing agent and it happens to, you know, देखो इन दोनों को, if you say both of these, if you look at these, the 0.11 volts is E naught value. मतलब that reaction will happen. Whereas if you compare these two, it will not happen. It is minus 0.02 volts. ठीक है? Okay, clear? Pi and psi, I showed you. Yeah, MnO4 and Cl minus बताया तो 0.11 volts, right? 1.51 minus 1.40, right? Yeah. See, one more thing. You're like, अरे इसने आशीष ने तो डेल्टा G naught वाला काम तो किया ही नहीं, कैसे? How can you tell? देखो, When you form a redox reaction, then delta G1, delta G2, and that whole, the final G will have the same values here. Yeah, I'll show you that also. I'll show you that also if you want. Maybe ye wala part. When we do Durst equation, we'll do that. Don't worry. Okay? I'll show you how we can do this for a reaction. I think we did that in the last class. हमने किया था. For a reaction, you can just subtract. Yeah. Although E naught is intensive, for a redox reaction, you can add and subtract E naught. But agar if it's only reduction or only oxidation halves, then you have to use that delta G wala value. I think that is what is concerned. Sahina, yes, it is an oxidizing agent, but not as strong as MnO4 minus. देखो, if I compare these values, I get a negative 0.02 volt potential between this and this, है ना? So ये reaction नहीं होगा. मतलब Cr2O7 will not react with HCl. Hence this is okay, this is okay, this is okay. This one is not okay. ठीक है? चलो आगे बढ़ते हैं. आगे बढ़ते हैं. Given C E naught of copper 2 plus and Sn2 plus, which of the following statements is incorrect? Try karo. This can have a good question. All right, nice, nice, nice. Which one of these is incorrect? More than one correct. Okay. Organic maybe hai. Yes, yes, sure. Can you try this out? Padhiye. Yeah, man, sitting for long hours, like weird leg things. Anyway, karo koshish. Cu2 plus likes getting reduced. Sn2 plus does not like being reduced. Sn2 plus is like got a negative value. What does this tell you? This likes being reduced. This doesn't like being reduced. This likes being reduced. This doesn't like being reduced. This compared to hydrogen still doesn't like being reduced. This compared to hydrogen हो जाएगा नहीं. हाँ, हाइड्रोजन के कंपैरिजन में ये रिड्यूस हो जाएगा, हाइड्रोजन कंपैरिजन में वो रिड्यूस नहीं होगा. Are you able to see that? Are you able to see that? Try it out. Try it out. If you need a help, if you need a bit of a help, I'm here. I'll give you a minute. Think about this. It'll take some time. Yeah. More than one correct, you have to think about every option. ध्यान से. The hint is, think about it from the electrochemical series thing. Okay. So what this is saying is, let's call this 1, this call this 2. So the order is 2, then hydrogen, and then 1. I know it is not H, it is H2 and H plus or whatever. जो भी है, ठीक है. इसका है 0, इसका है negative 0.136, इसका है 0.337. ठीक है. I know the E-Chem series is उल्टा, Electrochem series is the other way around, but ठीक है. जैसा भी देखना है तुम लोग देख लो. Sahina saying D. Okay. Good job on that, Sahina. But I think we may have more things that are correct. Sai and Pi and Shankar are all saying B, C, and D. And I would like to, I'm quite inclined to go with all three of them. Absolutely right. B is wrong, Sahina. अच्छा, ठीक है, देखते हैं. Copper can be oxidized by H plus. Sahina ji, I think B is correct. I'll tell you why. You're right. B, C is correct. I'll take some space to write down. देखो, अगर कॉपर हो रहा है ऑक्सीडाइज बाय H प्लस. ओ हाँ, B इज इनकरेक्ट. सॉरी, इनकरेक्ट ही तो पता करना था ना. हाँ सही ना, B इज रॉन्ग. करेक्ट. तो B and D is what you're saying, सही ना. देखो C भी incorrect. You're right. You're right. You're right. Yeah, incorrect, right? Copper can be oxidized. It cannot, right? Because अगर copper हो रहा है oxidized, then the E naught becomes negative, right? If copper is oxidized, then E naught is going to be negative 0.337 volts for this. So it's incorrect. Sn2 plus can be reduced by H2. ये भी सही नहीं है. Because if it is being reduced, then again E naught is going to be negative 1.136. नहीं, 136, right? Hence ये भी नहीं होगा. Copper can reduce Sn2 plus. देखते हैं. Copper reduce Sn2 plus. मतलब कि ये हो गया negative 0.136 minus 0.337. Again E naught is negative. Again ये भी नहीं होगा. What about this? Copper can be reduced by H2. ये तो होगा ही ना. अगर ये हो गया तो E naught is going to be what? 0.337 minus 0. This is good. This is positive. Positive and ये CNC वाला सही है. Okay. So sahi na, you're absolutely right. C bhi incorrect hai. That's what I was trying to say. Good job, Sai and Pi. Sai and Pi rhymes. And Shankar. Good job, good job, good job. Back to that question about how can we get sustainable current. 4-5 मिनट का ये, let's finish this off. Add a salt bridge. Salt bridge पे भी एक बार सवाल आया था. I think they've stopped. आजकल salt bridge पे सवाल नहीं पूछते हैं. But अगर गलती से पूछ लिया तो you're prepared. Okay. What does a salt bridge do? Yeah, you've got this whole thing. Zinc rod anode. You're still talking about Daniel cell. Okay. Daniel ऊपर लिखा है. Daniel भाई साहब. Zinc sulfate solution. Electron flow कैसे है? ऐसे. Oh, that way. Yeah, okay. So that way down and that way. Why? Because this guy furnishes electrons, right? Electrons come out of here, 2 electrons. And this person consumes electrons. Why? Because CO2 plus electrons gives you Cu. In this case, Zn gives you Zn2 plus electrons. Okay, here. Okay. What does this salt bridge do? It's a U-shaped tube. It has a gel which has inert electrolyte. Inert मतलब potassium chloride अगर jelly में. मतलब कि potassium और chloride जो ions है और या फिर potassium nitrate, they have similar mobility. So it connects the solutions and it completes the circuit. तो वो जो थे ना जहाँ पे ज्यादा Zn2 plus ions बने solution में और also कम copper 2 plus ions थे, तो what happens is कि some counter ions आ जाते हैं. अगर ज्यादा, let me go back to this one वो देखेंगे, LJP देखेंगे. So extra this plus Cl minus या nitrate या जो भी है, whatever is from salt bridge, or you know fewer, what do you call it, CO2 plus, more K plus from salt bridge. ठीक है. So it connects the solution, keeps it electrically neutral, minimizes the liquid junction potential. What is liquid junction potential? So अगर दो अलग अलग electrolytic solutions हैं, right, and they contact with each other, there will be a sort of a potential difference because there is a difference in the speed, the mobility of the ions. This is in the second half, okay, of electro. What second half? When we talk about ionic conductance. Actually वहां पे हम लोग mobility की ज्यादा बात नहीं करेंगे, but जाहिर है कि if H plus is smaller than chloride minus, this is going to move faster and this will move slower, and that is a problem. If this moves faster and this slower, then देखो यहाँ plus or minus, this is a liquid junction potential. ठीक है. इसी को avoid करने के लिए we add ions of a salt bridge that they can move around and they have similar speeds. Okay, let's call it mobility. Let's use technical terms. They have similar mobility. So it's all chill. So they minimize the liquid junction potential. This part is usually not mentioned. ये थोड़ा extra information है. ठीक है. And electrical neutrality वाला part I already told you how. ठीक है. Continuous flow of current. That's it. That's it. ठीक है. So it has K plus NO3 या फिर Cl minus हो जो भी हो. They have the same amount of velocity and mobility. So once you do that, then all is well. And finally, yay! The bulb glows. Shankar is still saying B is not wrong. Okay. No, Manoj. I know it's called a salt bridge, but sodium और potassium में बहुत फर्क है. Potassium and chlorine have similar mobilities. Sodium, not so much, right? And nitrate ions as well as potassium has similar mobility. That's an interesting question. अगले क्लास का टाइम हो गया है. 8 बज रहा है, 9 बज रहा है. अगला कौन सी क्लास है? You have one more class. We are done, right? I mean, what other class do you have? Khair, I think I'm done with this. Yeah, pretty much done. I'm just going to quickly finish it up. Yeah, it ensures that two electrolytes don't mix, but the diffusion of ions is possible. Okay, I'll give these notes to you. Don't worry about it. It's a simple cheez hai. Khair, it is not required for a galvanic cell which has a common electrolyte or anode and cathode half is present, which means concentration cell में जरूरत नहीं है. In fact, even a regular galvanic cell, the cell will work without it, but it will just stop sooner. ठीक है, ये जरूरी बात है. Listen to it. I'm saying it once again. For a regular cell also, it's not like cell will not work without salt bridge. Salt bridge is good to keep the cell function. ठीक है, and it is absolutely not required अगर electrolyte दोनों में same है. ठीक है. And this was the thumbnail of this whole thing. Salt bridge finishes up. I'm quickly gonna go back and Shankar, you can carry on, man. Somebody asked a question, right? No, dude, Manoj, not really. Shankar, this is an English class. Do you want me to speak more in English? Tell me. So my goal is to reach the most amount of audience, the majority of the audience. So I'm speaking in Hindi and in English. so I can do a little bit of both. Yeah. Okay. Darkest. You're from there. That's beautiful. Yeah, video's blurry. It's weird. I know. It's okay. It's okay. Nahi, bhai, Manoj. Sun to lo. I've said it 3-4 times. Hold on. I'm done with the session. If you guys want to carry on, chale jao aap log. I'm done. I'll give you homework questions very quickly, and then I'll address somebody saying ki, sir, kuch aur aap bol rahe the na. I'll get back to that. Couple of questions for you. Homework questions. Here's the first one. Which of the following ions does not liberate hydrogen gas on reaction of dilute acids? That's the first one. Okay. And this is the next one. Interestingly, इसी सवाल को थोड़ा बदल करके it came in JEE Main 2023 as a numerical entry. Same question. थोड़ा सा बदल के. ठीक है. Anyway, try this out. That's all I have for you today. You guys can carry on. I'm done with the session. 2 homework सवाल है. Please करो. I will go back and try and address what this guy said. क्या बोला उसने? कुछ B वाला कुछ बोला ना? Shankar, कौन सा B is correct? You can carry on if you want. I will address what Shankar was saying. Shankar भाई, थोड़ा जल्दी बताओ. What do you mean by B कुछ बोल रहे थे ना आप? कौन सा वाला? This was not here. This was copper can be oxidized by H plus. Nahi, Chinna, I'm not Karnataka. I'm from UP, Allahabad, Prayagraj, but I've been in Bangalore for like 25 odd years. Yeah, we can do some time pass. You can carry on. दोस्त, कहाँ हो शंकर? भाग गए? Are you here? देखो यार, if this is correct, if this is incorrect, then this has to be correct. They are opposite, right? Both of these are opposite. Cu can be oxidized by H plus. Okay, let us see. Since आप बोल रहे हो, we'll see again. ध्यान से देखते हैं. Copper can be oxidized by H plus. If copper can be oxidized by H plus, matlab I have written over here that E0 cell is positive. Okay. If copper is being oxidized by H plus, so that means that copper is the anode, right? Then this should be the anode and this should be the cathode. Okay. इसका तो हो गया 0. इसका हो जाएगा negative of reduction potential. What is this? This is negative 0.337, right? So E0 is going to be equal to negative 0.337. Hence, not spontaneous. ठीक है? So, hold on. Oh, okay. That's what you're saying, huh? Copper can be oxidized by H plus. Copper can be oxidized by H plus. I see. So, yeah, this is incorrect. You have to say this is incorrect. So, what are you saying? You're saying it is correct. I'm just going to scroll up again. Shankar, sir, B is not wrong. Dekho, B is wrong. I've just explained. Shankar, everybody else can carry on. The class is done. Class छुट्टी हो चुकी है. तुम लोग जा सकते हो. Since Shankar had an issue, I am explaining to him. क्योंकि ये जरूरी है. This is the most important takeaway from the session. अगर नहीं समझा समझ लो. Shankar, you good, bro? सब ठीक है? If copper can be oxidized, that means copper must be an anode. If copper is anode, then I have to reverse this reaction. If I reverse this reaction, उसका हो जाएगा minus 0.337, right? Right. और अगर ये line of thinking तुमको अजीब लग रही है, if you find that to be weird, Shankar, then I write it down like this. E0 cell is E0 cathode minus E0 anode. Okay. Now, when I do minus E0 of anode, that's minus 0.337 because this is 0 anyway. है ना? ठीक है, boss. Is that okay? If you still didn't follow, ping me on iTeach Chem. I'll try and help you out, I guess. ठीक है? All right. See you. Good night. Shabba khair. All of that. Hari bol. I'll see you guys next week. No. I'll see you guys this weekend. We're going to do some questions. Thermo and atomic structure and all that. Ana, PYQs, bro. Last वाला thermo का. We'll do equilibrium, thermo का combination वाला questions, entropy, Gibbs energy, all that. Cool? Okay. Homework questions once again. If you missed them, first question, please try it. Next question. Bye. Good night. I'll see you on Saturday on the JEE channel. NEET पे मिलेंगे Tuesday को. अगर कोई NEET वाला यहाँ पे है. Bye.